Okay, so now our recording should go right to that folder. So for our do now, the first question says, find the domain and range of the relation, and then is the relation a function, y or y not? So let's start with the first part of our problem, and that is we're finding the domain and the range. So first of all, when I'm looking at domain, which values am I looking at? Yeah, I'm looking at my first values, my x values. So I'm just going to write that so we remember. And then since we know domain is x, range must be y values. Thank you. So totally optional, but I'm going to go ahead and label my x's and my y's just so that I don't lose track. All right. Here we go. So for domain, what answer did we get? Thank you. So we got our bracket, then what numbers?
2, 3, 4, 5.
Perfect, and that's all. Close the bracket. 2, 3, 4, 5. We don't have to write that last 2 because we already wrote a 2 there at the beginning. Okay, let's move on to range. Now we're looking at y values. We'll start with a bracket just like domain. What are our numbers? Perfect. 3, 5, 7, 9. And just like in the domain, we don't have to write that last 5 because we already included a 5 right here. Okay, we have found our domain and our range. Now on to the next part of the question. It asks, is the relation a function, y or y not? Ooh, okay, so we said no because there are duplicated x's. So just for a little bit of extra reassurance that we got it right, I'm going to draw the xy chart. And we are going to list out our x and y values to make sure that every x has only one y. So in my x's, I have a 2, a 3, a 4, a 5, and I don't have to write 2 again. So we're going to put 2, 3, 4, 5. All right, now I'm going to look at my corresponding y's. 2 has a 3 for y. 3 has a 5 for y. 4 has a 7 for y. 5 has a 9 for y. And then 2 also has a 5 for y. So we can see here that my x value of 2 has more than one y value. And if any of my x values has more than one y value, we automatically know this is not a function. So the answer to is the relation a function, you would say no, because it asks you why. You could say a couple of things. You could say the x value 2 has more than one y value, or you could say something along the lines of not all the x's have just one y. What do we want to say here for our explanation?
I put too many partners.
Ah, too many partners. Oh, yeah, I'll say no because one of my x's has too many partners. All right. And then because it's our answer, we'll circle it. Just get in the habit of circling our answers. Same with domain and range. We're going to circle that so they don't get lost. Any questions about number 1 before we check number 2? Okay. Let's look at number 2 now. We have, is 510 a solution to 4x minus y equals 20? How do we solve this? Any ideas?
We would do 4 times 5.
Ooh, so we would do 4 times 5. Why are we doing 4 times 5? You're right, by the way.
Because we already have the x.
Yes, all we do to see if a coordinate is a solution of an equation to a line is we take that x value, the y value, and we plug it into the equation to see if it creates a true statement. So we're going to do exactly that. Like what Michael said, we did 4 times 5, because 4x means 4 times x. X is 5. 4 times 5. Then we have minus y. And yeah, y is 10. So we can just write in 10. And what else do we need to write to find this out? Equals 20. Perfect. Okay, so now we have our numbers set up. No more variables need to be plugged in. We're going to do 4 times 5, and that is 20. Then we bring everything down. We've got 20 minus 10 equals 20. Now what?
Subtract 10 from 20.
Absolutely. You could subtract 10 from 20 just to complete it, but we could also look at this and know that if I have 20 and I'm taking 10 away from it, there's no way that's going to be the same thing as 20. So just to give you some closure here, 10 equals 20. If that's not true, we are going to draw a slash through our equal sign. This means 10 is not equal to 20. So we're going to circle this because it's part of our answer. Yes?
So I was, after I got this 10 equals 20, I was dividing both sides by 10.
Ooh, so what do you think brought you to want to divide both sides by 10?
Just because the equal.
Because of the equal. Okay, so on a question where we're solving for a variable, like if we still had an x somewhere in here, you would have absolutely done the right thing. That would be correct. But since we already plugged our variables in and we're not solving for anything, all we're trying to figure out is, does this make a true statement? Is 10 equal to 20? And here we found out it doesn't. It's not true. So for your answer to, is 5, 10 a solution to 4x minus y equals 20? Is it a solution?
No.
No, it is not a solution. Perfect. Okay, so whenever you answer a question like this, make sure you circle that statement that you came up with to show that it's not true, and also circle your no. Just don't want it to get lost in anything. Okay, does everybody understand number 2 all right? Any questions before we try 3? Okay, let's move on. Number 3 is a very similar problem. I'm going to label my x and my y again just so I don't lose track. Okay, I have -2, 6, and I want to know, is that a solution to y equals x plus 9? What is my first step? Yeah, we're going to plug our numbers in. We have a y by itself here, so I'm going to go ahead and write 6 because I know that's my y. I've got 6 equals, and then x plus 9. What's x? -2. We're taking it straight from that coordinate. So -2 plus 9. All right, does everyone see how we got to this point? Perfect. Okay, what do we do now? We got to solve it. So there's nothing to do on this side. We just have 6 equals. All we need to do is find out, is -2 plus 9 equal to 6? So what is -2 plus 9? 7. So we have 7 is equal to 6. Is that true? No. So we're going to put a cross through that equal sign. We're going to circle it. And then we're going to say, no, not a solution. We're going to circle that no also. Okay. Any questions on 3 before we try 4? All right, guys. Number 4 says sketch the graph of this line. We have y equals 5x minus 4. Who can tell me how we might go about sketching the graph of this line?
I just went 1, 2, 3.
Okay, 1, 2, 3. Where are you putting that 1, 2, 3? What are you doing there?
Put it next to the 5.
Putting 1, 2, 3 on the 5. Okay, so what Michael's doing is he's picking x values, and then what are you doing after you plug the x value in?
Solving for y.
Yeah, solving for y. So it sounds like he's coming up with 3 coordinates that he can put on a graph. So let's go ahead and start by drawing 3 sets of empty coordinates that we can plug in. And I like those numbers, 1, 2, 3. Let's do those. 1, 2, 3. These are going to be our points that we plot. So to keep our work organized, I'm going to label these A, B, and C. And then I'm going to start with my work to find point A. We have the x for point A. We just need the y. So if it helps you stay organized, maybe just label everything. Okay, so for point A, let's put a little A right here. My original equation is y equals 5x minus 4. So exactly what Michael said, we're going to do y equals 5, our x is going to be 1, times 1, minus 4. Okay? Now what?
Drop down. 4 equals 5. Or 4 subtract 5 equals 1.
Yeah, so we have y equals, and then you did that, we know 5 times 1 is 5.
Yeah.
So we're really just doing 5 minus 4. And then you got 5 minus 4 is 1. Perfect. So the way that we read this now is we know that y equals 1 whenever x also equals 1. So we're going to take this y and put it in our coordinate A. That's what we just found. I'm just going to bubble that off so I don't lose track of what I did. Okay, let's go ahead and solve for point B. I'm going to make another little B. And we decided B, our x is going to be 2. So let's rewrite the equation. Got y equals 5 times x is going to be 2 minus 4. All right, now what do I do here?
Well, 5 times 2 is 10.
Perfect. 5 times 2 is 10. And I'll bring everything else down. Then what?
10 minus 4 is 6.
Perfect. 10 minus 4 equals 6. So y is 6 whenever x is 2. So next to my 2 for x, I'm going to put 6 for y. All right. Now we have one more point to solve for. So I'm going to write a C. And again, we're going to rewrite that original equation. We have y equals 5 times, we're choosing 3 for x, minus 4, just because that's the original equation. Now what are we doing?
5 times 3 is 15.
5 times 3 is 15, perfect. 15 minus 4, 11. Y equals 11 when x equals 3. So we're going to put 11 right here. All right, guys. So we have just found 3 points. What do we do next to graph this line?
Well, you gotta set up a graph first.
Absolutely, we got to set up a graph first. We don't know where to put it unless we draw the x and the y axis. So I'm going to start by making a little upward arrow, and I'm going to label this as the y-axis. It's going to go up and down. Okay, and it looks like my y goes all the way up to 11. So I just want to make sure I've got at least 11 points here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, maybe we're gonna do a half graph because I don't want to make it all the way down there. Let's just do this, and each little square block unit is gonna be 2 points. So I'll put them in between like this. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. Okay, and my x only goes up to 3. So we could make the scale different if we wanted to. That will affect the way that our line is, it'll affect the way the slope looks, whether it's more steep or less steep. So we do want to try to keep our scale the same way, where we have the same distance across from each other. You guys see what I mean by that? Even though we're only going up to 3, I know it will be a little bit smushed together, but I'm going to go ahead and keep that scale consistent. Yes, yes, it will be a steep slope. Okay, so we want to plot all 3 of these points. Let's start with point A. How am I going to plot the coordinate 1, 1?
Go over to the right one.
Uh-huh.
And up one.
Over to the right 1 and up 1. That is point A. Perfect. B, we've got 2, 6, so we're going to go over 2 and up 2, 4, 6. Be right about here. That's going to be point B. And for C, we're going to do the same thing. We go over 3 for X. Oh, I forgot to label my X-axis. There we go. And then up 11 for the Y. So we're going to go 1, 2, 3, 2, 4, 6, 8, 10, 11. Right about here. And that is point C. Okay. Now we have plotted our 3 coordinates. The directions tell us we need to be sketching a graph of this line. So what do we need to do as our final step here? Connect the dots, guys. That's all we're doing. So if you need a ruler or a straight edge, I have some up at the front of the room in that little bin. It's labeled rulers. You're welcome to get one. If not, you can just do your best to connect the dots. I'll be fine with either. And then I am going to draw a line through my points and make sure I've got arrows on both ends. That way it shows that this line goes forever in this direction and forever in that direction. All right, there is number 4, guys. Any questions about that? Do we all feel okay about these? Okay. All right, guys. If we're ready, I'm going to move us on to our notes for today. Are we ready? Do we need to write anything down up here, or can I move on?
I'm ready.
Okay. Everybody ready? Okay, awesome. Let's move on. So, today, let me get rid of this. I'm going to tell you all the topics that we're going to learn about. If you want to copy down my notes, that would be a great guide for you to have, especially for whenever we test later on, just so we can keep track and make sure that you've got everything you need in there. So our topics for day 12 are going to include, we're going to talk about slope-intercept form, which is y equals mx plus b. We've talked about that a little bit already. But we are going to learn how to identify certain parts of that formula. We're going to learn about slope. We're going to learn about something called a y-intercept. And then we're going to learn about something called an x-intercept. And finally, once we've learned about those 3 things, we are going to learn today how to draw a line or sketch a graph without plotting 3 coordinates. We're going to learn how to do it much faster today. So I'm going to give everyone a minute to get that written down. and then we'll move on to the actual notes. So once you get this far, the first kind of title that I have for you is identifying the parts of slope-intercept form. You don't necessarily have to write that exactly, but what I'm going to do is I'm going to give you those terms and kind of define them for you. Is everyone ready for me to move on, or do we need a minute? Okay, take your time. Ooh, and here's what I can do. I can pause the recording. Awesome. Okay, so the first thing that we're going to talk about is slope. Slope. I'm going to write that as our first little definition. So slope is pretty simple. It's exactly what it sounds like. The slope of a line is just how steep it is. So it's just the steepness of a line. All right. Now, whenever we are looking at slope, or you know what, whenever we're looking at any of these kind of parts that we're going to identify, let's reference one equation so that we can kind of identify the parts together. I'm going to write over to the side here, y equals, this is just an example, 2x plus 1. Okay, so when we're looking at slope, slope is the steepness of a line. Your slope is always going to be the m in an equation. So we see it's y equals mx plus b. So it's always going to be the number right next to the x. So in this equation, y equals 2x plus 1, what would our slope be? 2. So I'm going to underline this 2, and I'm going to call it slope. That is my slope. So in this case, m would equal 2. Now, this isn't going to make as much sense until we get to the graphing part, but I'm going to go ahead and have you write this down. Slope, or m, is also going to be equal to, we're going to call it rise over run. Rise over run. Just have that written down. We're not going to worry about it yet. We'll use it here in a minute. So slope is m, it's the number right next to x, and it's rise over run. Okay. Now let's move on and look at y-intercept. So I'm going to start a new term right next to, or under here, y-intercept. And a y-intercept is just the value or the number, the point where a line crosses over the y-axis. So I'm going to write that definition out for you and I'll explain to you what it means. So it's the value at which a line crosses the y-axis. So I'm going to draw a little picture to the side here, maybe to help. If I were to have a little graph here, and I know this is my y-axis, this is my x-axis. And if I were to have an equation that looks like this. Something like that. You will see that the y-axis here, the up and down axis, this line touches it right here. This would be our y-intercept. Now, without looking at it visually, yes, do you have a question?
Wouldn't that be the same as any point to 1, 0 for the x-axis?
Yes, yes, you're getting ahead of me. That's perfect that you recognize that. So what Erica just said is it's basically whatever point you get for y whenever x is 0. And let me explain that further. Don't get too confused yet. So whenever we're looking for y-intercept, we can also call it b. And I'll tell you what that means too. So in our formula, we have y equals mx plus b. That b is always going to be the plus something number at the end. So in this example, y equals 2x plus 1. Our y-intercept would be 1. So I'm going to label that. That would be our y-intercept. So whenever we graph this line, it's going to end up looking like the picture I drew. And you'll see, let me draw my tick marks so we can kind of see the scale here. When we go up 1, that's where our y-intercept is going to be. Just like on here. Yes, Dream?
Why isn't y just y?
Say it again.
Why isn't y just y?
Why isn't y just... I'm confused. Can you say your question in a different way?
If when y equals the y on the y-axis,
So wouldn't the y value equal...
I think what she's saying, instead of the y-intercept being 1, why isn't it actually just y on the problem? Y equals 2x plus 1.
Oh, okay. That's a good question. Why isn't our y-intercept just y? So this goes kind of back into the theory of math and the people that developed the way things are written. And I'm not a mathematician. I just teach high school math, guys. But the y-intercept, it's not telling you necessarily the y value. What it's telling us is where the line touches the y-axis. So as much as it would be really nice to get to say, oh, our y-intercept is the y value, it's just going to be this, y. It's just the way that they created math, I guess. If I could, maybe I can do some research and give you a better answer next time. But it might make more sense too whenever we go through the process of graphing. But this plus 1, that b, is going to tell us how high up we need to move the line. And that's going to be where it crosses that y-axis. And I apologize. I feel like I'm not giving this explanation much justice here. I would love to give you a better, more thought out answer. But I think for now, the best thing I can tell you is it's just what they named it when they created math. That's just what it is. Our y-intercept is b in this equation. So I wish it was x, or I wish it was y, that would make more sense, but it's just not. So our y-intercept is going to be b in that equation. It's going to be that number at the end. It tells us where it crosses the y-axis, where it touches, where that point's going to be. And the way that we can write it, you know what, Dream? Forget everything I just said. I have the answer. So, when you want to find the y-intercept, what you can do is set, I'm going to write this down for you guys. Set x equals 0, and then you're solving for y. And let me show you why that makes sense and what that means. So, as you can see on the graph, the point that we would have just plotted here would really be, we went over 0 for x, so x is 0. We went up 1 for y, so y is 1. If we were to solve for this in our equation, we would have y equals 2x. We're going to put x equals 0 plus 1. And then we're going to solve for y. So what we would do is solve this here. We know 2 times 0 is what?
0.
It's 0, so we just get rid of it. And what we come up with here is y equals 1. So it kind of is the y. It's just before we solve it, they label it with the letter b just because that's what they chose. But when we solve for the x or for the y-intercept, we are going to get y equals 1 whenever x equals 0. So to find the y-intercept, if you set x equals 0, whatever your y value is going to be that y-intercept. And I know this is a lot of letters and stuff going on. I hope this isn't too confusing. I think it's going to start to make more and more sense when we start putting these terms into action and actually start the graphing process. So when we look at the equation, whatever the plus is at the end, that's our y-intercept. And we can write it as a coordinate. When x is 0, wherever y is touching on the line, that's our y-intercept. Does that make any sense, or am I getting everybody more confused? Okay, good. Good. All right. So, finally, we are going to look at our very last term here. And I'm going to kind of put this down here. We've done slope, we've done y-intercept, and just for your information, we are going to learn about x-intercept. And I'm going to do that in, I guess, purple. Okay, so x-intercept is next. And if the y-intercept tells us where a line crosses the y-axis, I keep saying axis, where it crosses the y-axis, what do you think the x-intercept is going to tell us? Exactly. It's going to tell us where the line crosses the x-axis. So, yes, Erica's exactly right. It's also going to be the opposite. Instead of setting x to 0 to solve for y, we're going to set y to 0 and solve for x. So visually we can see that wherever the line touches this x, which right here, when I'm looking at it, it looks like it's probably going to be about -1/2 for x. But just to be sure, we would plug it in the equation and solve. So I'm going to write the definition for you first. It's the value at which a line crosses the x-axis. Now the x-intercept is not something that we can easily identify by saying that it equals m or b. It's something that we will have to solve for. So I'm going to label up here just how the y-intercept is. We set x at 0 and find y. We would set y at 0 and solve for x. So let me write that under here in parentheses. Set y equals 0, and then solve for x. Get that a little lower for everybody. Okay. So let's go ahead and figure out what our x-intercept would be for this equation, y equals 2x plus 1. We're going to set our y to 0. So we're just going to write 0 equals 2x plus 1. So I'm going to go ahead and write that down here. 0 equals 2x plus 1. And we're just going to solve it with our inverse operations. What's my first step to solving? Yeah, we're going to take that plus 1 here and we're going to get rid of it by doing minus 1 on both sides. All right, 0 minus 1, what's that going to give us? Negative 1 equals 2x, and those cancel. All right, now what do we do to get x by itself and solve? We're dividing. We have 2 times x. We're going to get rid of 2 by dividing by 2. And look at that, just like our picture showed. X equals negative 1/2. So, because we know that, oh my goodness guys, I wrote the wrong thing up here. If you copied me, cross it off or something. I'm leading y'all the wrong way. We solved for x, but I put x in the y spot. That's incorrect. Okay. Let me fix that for you. If you were copying what I just did, you copied something wrong. I don't want you to have it wrong in your notes. Okay? What it should be is we solve for x, and we're setting y as 0. Sorry guys, I don't mean to confuse you. So remember, our x comes first. We knew that y was 0. All right. Give everybody a second to fix that. I don't want anybody to be having the wrong thing. Okay. Now, we know that our coordinate is going to be whatever we found for x, which is negative 1/2. And then we know that we put 0 for y. So, if we go over to the little graph we made here, we can label this point negative 1/2, comma 0 for y. So those are some points that we can plot using the x-intercept and the y-intercept. Yes. Yes, negative 1/2 is not quite negative 1, but it's still smaller than 0. So it would go right there in the middle. Perfect. Okay. I know I might have confused some of you with that little oopsie right there. So does anyone have any questions about these 3 items here? Slope, y-intercept, or x-intercept? If you're totally confused and don't know what to ask yet, don't worry. We're about to put these kind of in context here, and hopefully it will make a bit more sense when we move forward. Okay, does anyone need more time to write? Okay, we're gonna go ahead and move on. So, let me make sure we're good on time too. Yeah, go ahead. We've got about 5 minutes. We will probably be continuing after lunch, guys. So I'm gonna have you come back when lunch is over. But for the next 5 minutes, let's go ahead and continue on. Yes? That is totally fine. This will be on YouTube for you to watch if you miss it.
All right, I got it.
Awesome, awesome, awesome. Okay, so flipping to the next page. What we're going to do now is we are going to practice sort of identifying these items. So I'm just going to write up here, day 12 continued, so I don't lose this. All right, so let's work out some examples together. I am going to give you this problem here. We've got y equals x plus 1. Okay, so that's our equation we're going to start with. Y equals x plus 1. And I want us to identify our slope, our y-intercept, and our x-intercept. So, to begin, I'm going to go ahead and write in for my y-intercept and my x-intercept. I'm going to put it in the form of a coordinate. And for my y-intercept, remember I don't know my y value, but I'm going to put a 0 for x so that I can solve for y. For the x-intercept, I'm looking for x, so I can put 0 for y to find x. So I like to start by putting those there. If it helps to label your x and your y, go ahead and do that. I mean, you just saw it a few minutes ago. I lose track too sometimes. Okay, so let's start with slope. Let's start with slope. How do we identify slope? Let's look back at our notes.
It should be in front of the x.
Yeah, it should be whatever number is in front of the x. Now, I don't see a number here. Would that mean that it's 0? 1. Thank you. Anytime that there is not a number in front of a variable, we know that there's just 1. So this would be really, if you want to write it in, 1x. We know that our slope is 1. So I'm going to write that in. Slope is 1. Okay. Now let's look at our y-intercept. What is our y-intercept? What can we do to identify it without even setting up an equation and solving for anything? Yeah, Dream, it is 1. How'd you know it was 1? How'd you know it was 1?
Because it's the last number.
Yeah, it's just going to be plus whatever this is here. This is b in the equation. Remember, it's y equals mx plus b. Our b tells us our y-intercept. We have a 1 right here. So our y-intercept is also 1. We're going to write it as 0, 1. Okay, now the only thing we need to solve for is our x-intercept. How are we going to find the x-intercept? What do I need to do?
Times it by 1.
Say that again?
Times it by 1.
Times what by 1?
The 1.
So what's making you want to times something by 1?
I don't agree with it.
That's okay. Let's look at our notes. It says to find the x-intercept, we're going to set y as 0. So we're going to plug in a 0 for y, and then we're going to solve for whatever x is. So let's look at this equation now. We have y equals x plus 1. So we need to set y to 0 and solve for x. So let's go ahead and do that. We're going to put 0 equals 1x plus 1. Is anybody lost about what I just did there? Okay. All right, now we just need to solve for x. So what are we going to do here? Yeah, we got to subtract 1, get rid of it, our inverse operations. So the 1's cancel. I've got -1 equals x. And I'm done. Okay, so what's my x-intercept? -1. So I can put that here in this coordinate. My answer is -1 with a 0 for y as my x-intercept. Okay, now here is where we can go from here as far as graphing. And yes, Dream. Yes, we have 0 minutes. Okay, guys, quick pause. All right, so now that we have identified our slope, our y-intercept, and our x-intercept, we are going to graph this line. So we first need to go ahead and make our coordinate plane and label our x and y axis. So I am going to draw an up and down line here for my y axis, and I need to label it. And same thing for the x, and then we'll label it. So now we have our y-intercept, and we can go ahead and graph that point on our line, or on our graph here. So let me make some little tick marks so we know what our scale is. Each box is going to be 1 unit here. And for my y-intercept, I have x is 0, y is 1. So I'm going to go over 0 in the x direction, and I'm going to go up 1 in the y direction. So I'm going to label this here as 0, 1, just like that. Okay, now we have our x-intercept 2. It says for our x we have -1, our y is 0. So where am I going to go in the x direction for the x-intercept? To the left, to -1. And do we go up any? Nope, our y is 0. So this is going to be our point for the x-intercept. So we're going to label that -1, 0. Now as you can see, those 2 points are going to tell us where the line is going to touch the y-axis or the x-axis. And now here's the part where slope comes into play. So if you look earlier in your notes where we said slope is the same thing as rise over run, here's what that means. First of all, I'm going to take my slope of 1 that I found by looking over here, and I'm going to rewrite it as a fraction. So anytime you have a slope that's a whole number as a fraction is just whatever that number is over 1. So I'm going to put 1 over 1. And just to label for reference, I'm going to remember that when I'm doing slope, I'm looking at rise over run here. So in the future, and I'll show you this with the next problem we do, if we don't want to have to look for the x-intercept and do all the solving, we can just look and see, okay, my y-intercept is 1, so I know on the y-axis my first point's going to be at 0, 1. Then I can look at my slope and say, my slope is 1 over 1, so I can do rise over run to find more points on my graph. So what that means is from this point here, every time I rise up 1 in the y direction, I can also go over 1 in the x direction. So since my slope is 1 over 1, I could start here and go up 1, over 1. Here's another point on my line. My slope never changes, so I can do this forever. Rise over run. I rise 1, I run 1. There's another point. Rise 1, run 1. There's another point. And you'll see that we're going to have a pretty consistent looking line here because our slope is going to tell us how steep it is. So we've got our points. We're just going to draw a line through them with a straight edge. So I'm going to line that up nicely, and I am going to draw a line with arrows on either end to show that it goes on forever and ever in both directions. Okay, so there's our line for y equals x plus 1. Let's try another example. This time we'll do a problem that does have a fraction for a slope. Let's try y equals -3/4 x minus 2. So the things that I want to find in this equation are the slope, and I know I put the slope and all the intercepts over here last time, but I think I'm going to put it under my problem this time, if that's all right with you guys. I'm going to write slope, y-intercept, and then we're going to find x-intercept. Hello. Okay. So first off, right off the bat, just by looking at my equation and not solving anything, what's my slope going to be?
-3/4.
Absolutely. My slope is just the number that sits next to x. It's going to be -3/4. All right. Now I'm going to look for my y-intercept. Just by looking at my equation without doing any math, what is the number that is going to be y for my y-intercept? -2, -2. So we need to make sure that we pay attention to the plus or the minus sign here.
I always do that.
Yes, yes. So on this first problem, we had a +1 as our y-intercept because it was +1. Since it's -2, our y-intercept is going to be negative, absolutely. So we can start by writing -2, but we also know that the point for the y-intercept is going to be where x equals 0 and y is -2.
And that negative sign.
Yep, can't forget the sign.
I know.
All right, now let's find our x-intercept as well. Whenever we're looking for our x-intercept, who can remind me, what do I need to set to 0 to solve for x? Yeah, we need to set the y to 0, because if I set this at 0, that's going to tell me that when I am at a 0 height, that means I'm not going up any higher, then whatever x is, that's where it's going to be touching the x-axis to give us that x-intercept. So I am going to go ahead and write my coordinate here. It's going to be something for x and 0 for y. Okay, so let's go ahead and solve that. Let's do 0 for y equals -3/4 x minus 2. What is our first step? Add 2, absolutely. We want to use those inverse operations. So we have 0 plus 2 is 2. My 2 2's cancel. We're going to bring everything down. We've got -3/4 x equals 2. Where do we go from here? This is the tricky part, guys. We haven't done a whole lot of fractions in here.
Divide or multiply the 3/4?
So we have here negative 3/4 times x. There's a couple things that we could do here. First, we could see that we have like a 3 divided by 4, and we could start by multiplying 4 to both sides and then divide by 3. Or we could just say this is the whole number that we are multiplying, so we could divide by negative 3/4. So it's kind of the exact same thing, just you're writing a number that's got a fraction in it here. So on our calculator, if we wanted to do this, we would do, here, let me rewrite that over here as well. We're taking 2 divided by negative 3/4. So I would type 2 divided by, and to show fractions, I like to just put them in parentheses, negative 3/4, close parentheses. Does everybody see that?
How'd you make the fraction?
So we don't have a fraction sign on this calculator, so instead we use the division symbol, because a 3/4 is the same thing as 3 divided by 4. So I'm going to delete that, but I want to make sure everybody understands how to type that on their calculator if they need to. Does everybody see how to do that? Is anyone confused? Okay, so we're going to go ahead and hit enter and see what we get. And we got a beautiful number here, negative 2.6 repeating. So that means, yes.
Question.
Uh-huh.
I know this is what confuses me. When I was in school, anything over 5, you rounded it up. So would that not be 2.7?
You absolutely could put it as 2.7. If you wanted to round up, I'm not going to count it wrong.
Okay.
Basically the same
But
thing.
we're just going to put 2.6 to make it easier?
So what we would do is put 2.6 repeating, and I'll show you how to write that.
All right, perfect.
So the negative 3/4, they cancel over here, and let's bring down our answer. We got negative 2 point, and when we have a repeating decimal like this, where it goes on forever, the only reason it says 7 at the end is because the calculator rounded up for us. We would put this little symbol above our 6. That means that it repeats. Negative 2.6 repeating equals x. So we know now that whenever y is 0, x is negative 2.6 repeating. So we're going to write that in over here for our x-intercept. Negative 2.6 repeating. Or 2.7. I will take either answer. All right. Does everybody understand how we got to this point? Good. All right. Now it's time to graph. Let's graph it, guys. Let's start with a nice up and down line here. Label it y. And then we need to label an x-axis as well. I'm just going to put it over here. Okay. Now, we're going to start with our y-intercept. We found the point 0, 2, or 0, negative 2. Sorry, guys. So, let's go ahead and start by plotting that point once I get these little tick marks ready. So that means we're going to go over 0 in the x direction. And in the y direction, we're going to go down 2, negative 2. So here's 0 for x, negative 1, negative 2. And this right here is going to be my y-intercept. It's exactly where my line crosses the y-axis. So I'll label that 0, negative 2. Okay. Now, let's look at our slope. We have a negative 3 over 4. I'm going to write that over to the side here. Negative 3 over 4. And we're going to remember that slope is the same thing as rise over run. When we had a positive slope, we would rise by going up 1 over 1, up 1 over 1. Since we have a negative number this time, we're going to go down 3 over 4. So let's start with our y-intercept here, and we're going to count our points down and over. We'll go 1, 2, 3, and then our run is 4. So 1, 2, 3, 4. And there's another point that we have. So we'll count that point. Our point is 1, 2, 3, 4 for x. And it's negative 1, 2, 3, 4, 5 for y. So there's a point that we found. Now, just because we got a decimal for the x-intercept, we're just going to leave that there. I just wanted us to see how to find it, but we're not going to worry about graphing it for now. We're going to just connect these 2 dots that we found. So we're going to line it up, and we're going to draw a nice pretty line right through it. And don't forget your arrows on the ends. Alright guys, that is going to be our line for y equals negative 3/4 x minus 2. Okay. Any questions about that? Okay, wonderful. Let's do one more together. Let's try y equals 4/5 x minus 2. Okay, now this time I'm just going to ask you to find the slope and the y-intercept. And we're going to see how easy it is to graph an equation with just those 2 points. Okay, so without doing any math, what's my slope? 4/5. Perfect. And again, without doing any math, what's my y-intercept? Yes, it's negative 2. So, since we know that's our y value, our y is going to be negative 2, but we know that y is negative 2 when x is what? 0. And we can remember that by looking here at this equation. If I made 0 here for x, 4/5 would disappear, and we would just get y equals negative 2. So we can write for x 0, for y negative 2. Okay, we've done no math so far. Let's do a graph. We haven't had to make any points. We can just look at the y-intercept and the slope and come up with a line. So we're going to draw a little graph here, label our axes. What's the first thing we should do? Well, can we do a slope if we don't know where we're starting? Yeah, let's go ahead and start with our y-intercept so that we have a starting point, and then our slope can tell us where to go next. So maybe that's misleading that I wrote slope first, but we are going to look at our y-intercept first. So we have 0, negative 2. So now let's look at our graph. We're going to go over 0 and go down 2. 1, 2. Okay, and we'll label that 0, negative 2. All right. Now we can look at slope. What does our slope tell us to do? Say that again? rise over run. And if you need to label that to help, go ahead. Rise over run. So that means our rise is 4, our run is 5. So we're going to start here from our point 0, -2. And how many are we going to go up? 4. So we'll go 1, 2, 3, 4. And then how many are we going in the run? 5. 1, 2, 3, 4, 5. And just like that, without having to do any math to find any coordinates, we have 2 points which we can connect to make a line. Now let's label this coordinate. Our x is going to be 1, 2, 3, 4, 5. What'd you say? Okay, okay. Then we need to label our y, which is 1, 2. Yes.
When you count that, do you start at the 0 or start at your point?
You start at your point. That's a great question. When you are plotting your next point using slope, always start at your y-intercept. That's going to tell you how far down your line is. If I were to start from 0 and go up 4 over 5, it's going to give me the wrong slope. Because when my lines connect, it's going to be too steep. That's why we start from the y-intercept. That's a great question. I'm sure somebody else is going to make that mistake later on. So hopefully we can nip it in the butt here. So now we have these 2 points and all we got to do is connect them. Yes,
I have a question.
absolutely.
Never mind.
Are you sure? What is it?
Nope, I answered it myself.
Okay, okay.
Won't you ask if maybe we have an issue too?
Yeah, what were you going to ask?
Yes, please.
For whatever reason, I thought that we wrote y first, 5 being y, but it wasn't.
Oh,
That's why I asked if you went up from the point.
yeah.
Because I thought you counted from your -2.
Yes.
That's how you got that.
So let's label our x and y so we don't get confused. I think the fact that slope is called rise over run can be a bit misleading because when we plot points, we always do x first, which is the run, and then it's y. But when we're plotting slope, we do our up and down first, and so slope is the only exception where we are rising first, then running. When you plot points, always do your x first because it comes first. Your x is going to tell us how many over we go, how many up we go. So when I'm labeling my point, I am labeling based off of my axis, not based off of this. So I counted over 1, 2, 3, 4, 5 for x, and I counted up 1, 2 for y. So this is just to label my coordinate. But if we want to see a visual of the slope, here's how we can show it. I'm going to draw this. And here, we can see that our rise was 4. And our run was 5. And we started from the y-intercept to find that.
But does that include the 0 when you do the rise? You know, the starting point?
Yes, so you're just counting tick marks. So here's my point.
Okay, so just the tick.
Yeah, so I'm going up 4. That means I'll go 1, 2, 3, 4. Just like that.
Okay.
And then from there I do my run. I count 5. 1, 2, 3, 4, 5. Does that make sense?
Yes.
Okay, good.
Yes.
Good.
This is the exception. When you said slope, so that's the exception?
So slope, whenever I say rise over run, and maybe I shouldn't have even said anything, I don't want to confuse you guys, but whenever we're graphing points, like we start with x and then we do y, so we know if I'm going to graph my y-intercept, I'll go over 0 and then down 2. The reason I mentioned that slope is kind of an exception is because in this case, we go up and down first, and then we go left to right. When we're plotting points, we start with left to right, and then we go up and down.
Got it, okay, so.
Okay. Let's do one more together. Wonder if I can fit another on this paper. Let's see. Y equals, let's do negative 2x plus 1. Okay, so let's find our slope and our y-intercept. Okay, so just by looking at that equation, what's my slope? Negative 2. Now, remember when we write it as rise over run, we need to turn this into a fraction. So over to the side, I'm going to turn negative 2 in a fraction. So I'm going to write rise over run. And how would I make negative 2 into a fraction? Just negative 2 over 1. Perfect. Negative 2 over 1. So that way I know whenever I get my y-intercept and then I start using my slope, I know I'm going to go down 2 over 1. All right. Now what's our y-intercept? 1. We know that because it's just the number at the end. It's going to be 1. So how would we write that as a coordinate?
0
Mm-hmm.
for x and then 1 for y.
Perfect. 0 for x, 1 for y.
Yeah.
All right, we've got a y-intercept, so we've got a starting point, and then we've got our slope, so we know that we're going to go somewhere from that starting point. Let's go ahead and draw a graph. And label our axes. We've got a y here, we've got an x here. Okay. Make some little tick marks.
And don't reach down to the positive.
Yes, absolutely. Don't forget my negatives are on the left, my positives are on the right. All right. First step, what should we do?
Go ahead. No,
You have it, Star.
Yeah.
You were saying it.
Go down to,
Oh, from where? What's our starting point?
the 0, this.
Yes, the 0, 1, our y-intercept.
Yeah,
So
thank you, y-intercept.
we always want to start by graphing our y-intercept. That is our starting point. So we're going to look at our x value, and that's 0. We don't need to move in the x direction. And our y is 1. So we're going to go up 1 right here. And we'll go ahead and label that 0, 1. Okay, now we can do what you were saying, Star. We can do the slope. We're going to look at our rise over run. We've got negative 2 and 1. So what direction are we going to go? Yeah, we're going to go down since it's negative. So we'll go down 2, so 1, 2, and then over 1. There is a point. We could leave it there if you want, or you can always keep going with slope. Once you have another point, you've got another starting point. You can go down 2 over 1. And you'll see that they'll all connect really nicely. You could do this for infinity. Down 2 over 1. So we've got a bunch of points. Let's just label at least one other point. I don't care which one. We could do this one, which would be x is 1, y is -1. If you wanted to label this one, you could. It would be x is 2, y is 1, 2, 3, -3. And we could just keep going. 3 is 3, 4, 5, -5, I believe. And you don't have to label that many points. I'm just showing you. And now from here we connect the dots. And we've got a nice pretty line. Okay. Any questions about that? Does anybody need more time to finish writing all that? Can we move on? Okay, so that is going to be all of the new material that I am going to give you today. I don't want your brains to explode. So, too late, she says. I'm not going to, man, I shouldn't have done that. I'm giving you all the answers. I'm going to have to cut that part out of the video.